Actually, we didn't have questions, so I guess we can move to the next presentation. So the next presentation is named ReLand, Integrating Large Language Models Insight into Industrial Recommendation via a Controllable Reasoning Pool. And it's going to be presented by Changxin. Please.
Okay. Hello, everyone. Thank you for joining our presentation. I'm thrilled to introduce our latest work, ReLand, integrating large language models insights into industry recommenders via a controllable reasoning pool. My name is Changxin Tian, and I'm part of the team from NT Group and Zhejiang University. Before we dive into the detail, let's talk about the challenges that industry recommender systems face. Recommender systems are the cornerstone of personalized user experiences in many applications. However, traditional recommender systems are often trained on a closed-loop user-item interaction dataset, so they are in isolated environment and lack the open world knowledge and human-like insights. Fortunately, large language models have shown remarkable progress, and recent work shows that large language models have great potential to help with isolated issues. As you can see in the slider, they can be used as recommenders or as knowledge encoders. Even though there have been major advancements, integrating LLMs into large-scale recommender systems still face challenges. For effectiveness, LLM-based methods do better than traditional recommenders in cold-start situations. However, they don't perform as well as well-trained traditional recommenders in typical scenario. For efficiency, LLM need a lot of computing power, while industry recommenders must handle millions of users with millisecond response time. So, how can we integrate the insights from LLM into industry recommenders? Our solution is a reusable LLM reasoning pool. Building on the assumption that users with similar behavior can share the same recommendation rationale, we first deploy LLM to generate recommendations for a group of seed users. And then we use LLM generated rationales to efficiently enhance recommendation for the entire user base. Following this idea, we introduced ReLand, an LLM-enhanced recommendation framework. Specifically, our framework includes two phases, extracting insights with seed users and utilizing LLM insights via retrieval. And in the first phase, we design an adaptive sampling strategy to select a small subset of users as seed user, and LLM generate recommendations for this user, creating an LLM reasoning pool. And in the second phase, we match each user with a seed user and reuse the seed user's rationale to enhance traditional recommenders. Next, I will detail these two phases. In phase one, to sample high-quality seed users, we design an adaptive seed user sampling strategy. First, we have representativeness-aware sampling. Here, we use k-means cluster to group users into key clusters. Then we select seed users from each cluster to ensure diversity. Next, we have importance-aware sampling. This part focuses on important users with more interaction. Here, we give this user higher sampling probabilities to make sure they are well presented. By alternating between these two strategies, we create our seed user set. Once we have seed user set, we got LLM via the chain of shot promoting to generate rationale for recommendations. Here is how our prompt works. Specifically, our template includes 3 steps. In the step 0, LLM formats the user interaction data, and in the step 1, LLM summarizes the user preferences in a single sentence. And in the step 2, based on those preferences, LLM suggests categories and items to the user. Meanwhile, the traditional behavior encoders such as Zhiqiang and Zhang generate dense representation for each user based on interaction. So we can construct an LLM reasoning pool where the keys are the behavior representation of seed users that are generated by traditional behavior encoder. And the values are the recommendation rationales of seed users that are generated by LLM. This reasoning pool will be reused in the next phase. In phase 2, we assume that users with similar behaviors can share the same recommendation rationales. So we scale LLM insights to all users through Retrieval. Specifically, we encode the history behavior of user into representation matrix. Then for any user in the entire user base, we find the recommendation rationale by maximizing the inner product between their behavior representation and those of the seed users. After assigning each user an LLM-generated rationale, we design a fusion layer to combine the rationale with ID embedding in traditional recommenders. Actually, ReLand doesn't restrict how the text encoder and the fusion layer are set up. In our case, we use BERT and the attention mechanism respectively, just like the slider. In this way, the open world knowledge and the insights from LLM are smoothly integrated into recommendation. This is our introduced framework. In the phase 1, we construct an LLM reasoning pool, and in the phase 2, we retrieve LLM the insight from the reasoning pool. Currently, ReLand have been deployed on Alipay, serving hundreds of thousands of users every day. In the industry scenario, ReLand is deployed in a hybrid offline-online manner, data processing, and then offline training, and followed by online serving. The data processing, we sample about 75,000 seed users and collect their behavior data from the past 30 days. In offline training, we use ChatGLM 6B to generate rationales for seed users, and use BERT to encode this rationale to get the rationale embeddings. And we use Proxima to match each user with a rationale embedding. During online serving, the embedding is fed into the online ranking module as a feature. Okay, to verify the effectiveness of ReLand, we conduct offline and online experiments. For the offline experiments, we pick 5 public recommendation datasets and 6 backbones. We also compare ReLand with 2 of the latest LLM-based methods. Okay, the first table highlights the performance boost for traditional recommenders. Here, ID only refers to the base model, and plus F item is the model with added item feature. ReLand refers to the model enhanced by our framework. The results show that ReLand improves all base model and outperform their extensions with item feature across both collaborative filtering and sequential recommendation method. Compared to the latest LLM-enhanced method, Slim and ReLand have similar performance, but ReLand offer lower inference cost. Okay, in our ablation study, we can find that removing any module like a promoting strategy and adaptive sampling strategy leads to a decrease in performance. To explore the impact of the number of seed users, we discovered that sampling just 10% users achieve performance comparable to inferring for the entire user base. Okay, in our online experiments, we conduct a 5-day A/B test involving about 27 million users. Overall, ReLand achieved a significant improvement of about 3% in CTR and 1% in CVR. When analyzing segmented populations, we found that ReLand significantly improved recommendation performance for low-frequency users more than for high-frequency users. As shown in the slider, L1 refers to the low-frequency user group, and L5 refers to the high-frequency user group. Okay, in conclusion, ReLand integrates the power of LLM into industry recommender in a low-cost way. Extensive offline and online experiments have verified the effectiveness of ReLand, and ReLand have been deployed on Alipay, serving hundreds of thousands of users every day. Okay, that's all. If you have any question, please contact me with email. Thank you.
Okay, thank you very much. Changxin, yes, please. So to be honest, there was one question that was deleted once you show the results for sampling the user. So I'm going to turn back to the audience, see if someone has a question here. Okay, if not, maybe I can just ask one quick question. Since this is a multi-component system, it seems you're like evaluating the quality of the system at the end, like end to end. So did you have any try to like component-wise evaluate it? For example, on the like this reasoning generation that you were doing, could be that you're also generating a lot of false positive, false negative, some tuning. Is there any effort you have done to like component-wise evaluate them in the hope that we can get better results? I don't know if my question was clear or not.
So
So my question was that your system is composed of several components where you're like generating reasoning and there are other steps that is using those reasoning. Did you have any component-wise evaluation of these? For example, on the reasoning generator, did you do any effort to control what kind of data is produced there via LLMs? Or the main measure that here we have is the final quality of recommendation?
Sorry. My oral English is not good, so if you have any question, please contact me with email, and I will reply carefully.
Sure.
Thank you.
No problem. Thank you very much. Yes, please give a clap.